So the next segment is going to give you some examples of difficulties with human language that make it very difficult for NLP systems to understand them. The example in the box is time flies like an arrow. If you think about it, you will probably immediately come up with a very reasonable interpretation of this sentence. However, this sentence has more than one interpretation, and some of those interpretations may not be as reasonable or as grammatical as the one that you first thought about. What are the different interpretations? Can you think about them? Well, the most obvious meaning of this sentence was that time flies very fast as an arrow. Therefore, we can say time flies like an arrow. However, this is a metaphorical interpretation, and as you can imagine, computers are really not that good with metaphors. So they may just as well come up with other interpretations of this sentence that are much more literal. Let me run you through two such possible interpretations. In the first one, we start from a sentence like flies like honey, as in the insects called flies like to eat honey. Then we modify the sentence slightly to say flies like an arrow. I mean, this is just something else that they like. It's an arrow, it's not honey, but it's still a valid object of the verb like. And finally, we can change the sentence to fruit flies like an arrow. So some specific kind of flies like an arrow. So this is another valid interpretation of this original sentence. Yet another one is to think of the word time as a verb. So it's like you take a stopwatch and you use it to time the race. In that case, you can say, well, let's time the flies, and then we can go back to the original sentence, time flies like an arrow. Let me run you through some more classic examples of ambiguous sentences and confusing sentences in natural language. The first one is about Beverly Hills. Everybody knows that Beverly Hills is a city in California. If we teach a computer to recognize that, let's say, a compound like this is the name of a city, it will probably interpret the next one also as a city, whereas many of you probably have heard of the name Beverly Hills and know that this is actually the name of a famous opera singer. Another example is the boxes in the pen. This is an example from Yehoshua Bar Hillel from close to 100 years ago. This sentence has a very obvious interpretation if a box could be contained inside a pen. However, because boxes are usually larger than pens, it would have to have a completely different interpretation. In that case, we are not going to assume that pen is a writing instrument, but instead we're going to assume that the pen must be something larger than a box, or it could be the interpretation of pen as a place where animals live. This is very different from the pen is in the box, which very clearly talks about the writing instrument because it can fit inside the box. So the lesson to learn here is that word order can matter a lot. Next example is Mary and Sue are mothers. Let's think about this sentence for a second. How many mothers do we have here? Well, Mary is a mother, Sue is a mother, that makes two mothers. What if we say Mary and Sue are sisters? This sentence looks very similar to the previous one, and yet in most contexts it would mean that Mary and Sue are sisters of each other, and therefore they're not in the same semantic relationship as the ones in the previous sentence. Every American has a mother. How many mothers is that? Well, we assume that it means that there are roughly as many mothers as Americans, at least the same order of magnitude. But if we change just a simple word here to every American has a president, we're going to see that the semantics of the sentence changes a lot. In this case, there's only one president for all Americans, as opposed to the previous example where there were many mothers. And the final example is, we gave the monkeys the bananas because they were hungry. Who is they? Well, because they is the subject of were hungry, it must refer to monkeys because bananas cannot be hungry. Whereas in the next example, we can say, we gave the monkeys the bananas because they were overripe. Well, who was overripe? Well, again, common sense tells us that it was the bananas and not the monkeys. So the lesson to learn here is that two sentences may look very similar on the superficially, but then when you want to translate them into some semantic representation, you may not be able to do this in a straightforward manner because there are many subtle interactions that come into play. So let's now talk about the difference between syntax and semantics. Very often in the linguistics literature, people use stars and question marks to indicate that a certain sentence is incorrect. It's not grammatical in some way. And the difference between the two is that the first sentence here, little A has Mary lamb, this sentence is not syntactically correct. When you would expect to see a sentence like Mary has a little lamb, which has the correct syntactic structure. So sentences that are syntactically inaccurate are usually marked with stars. Now, what about the question mark? The second example from Chomsky 1957 says, colorless green ideas sleep furiously. Well, if you think about this sentence, it is actually syntactically well formed. It has a subject, just like Mary has a little lamb. In this case, the subject is colorless green ideas. It has a verb phrase, sleep furiously. And the whole sentence sounds syntactically correct. However, its semantics, its meaning is problematic in more than one way. What are the problems here? Well, the first one is that ideas usually don't sleep. In order to sleep, some entity has to have this capacity, and ideas doesn't fall in the category of things that can sleep. The second problem is that when you sleep, you usually sleep peacefully, not furiously. So the combination of sleeping with the adverb furiously is incongruous. And finally, we have colorless green ideas, which is problematic in two ways itself. Colorless and green are two adjectives, but they contradict each other. You cannot be both green and colorless at the same time. And finally, ideas cannot be described as colorless or green, or both, because ideas, again, don't have the property of color or colorlessness. So to summarize this slide, we want to make a distinction between syntactically poorly formed sentences, like the first example, and sentences that are semantically incorrect or poorly formed, like the second one. Then let's look at different kinds of word ambiguity. Let's start with three very simple words that you see every day: the word ball, the word board, and the word plant. What are the meanings of those words? Well, they have more than one meaning. Each of them has, in fact, as many as 10 or 15 different senses. What about the words fly, rent, and tape? Well, they can also be ambiguous, but in a different way. They don't just have different senses, they also have different parts of speech. For example, a fly can be a noun and to fly can be a verb. A rent is a noun, to rent is a verb. So this is a difference in part of speech. And the third category is the words that I'm just showing you here. Try to pronounce those words and see what they have in common. Just give it a try, and on the next slide I'll explain what they have in common. So let's look at the answers to the quiz. Address or address can be pronounced differently whether it is a noun or a verb. There are many other words like this. For example, transport versus to transport, effect and outline versus outline. Resent versus resent. For example, as a verb infinitive, it means to hate somebody, and resent means to send a letter a second time. It's pronounced very differently again. Entrance can be a noun, or it can be a verb, which means to put somebody in a trance, and they're pronounced very differently. Entrance versus to entrance. And finally, number can be either number, if it means the comparative of the adjective num, or it can just be the word number as a noun. Now, computer languages don't have this kind of problem of ambiguity. They're designed to be unambiguous. It turns out that there are also human languages that are unambiguous by design. One such example is Lojban, and the picture that you see next to the name is the official logo of that language. It was designed specifically to be unambiguous. There are examples of ambiguity also in what are known as noun-noun phrases. So a sequence of three words can be parsed either as a group of the first two that is then modified by the third one, or as a group of the last two, which is then modified by the first one. So which instance do we have here? Science fiction writer is of the first kind, where science fiction is a type of literature, and a science fiction writer is somebody who writes science fiction. Customer service representative. Again, customer service is a unit, and then customer service representative is a representative who provides customer service. So we again have the first possible interpretation. And then the last example is state chess tournament. If we try to parse this phrase the same way as the previous two, we would assume that state and chess are connected, and that is not the case. In this particular example, we have the opposite kind of grouping. Chess tournament is a unit, and then state chess tournament is a kind of chess tournament. So we have the second possible parse. Now I'm going to jump to a couple of problems from NACLO, which is the annual computational linguistics competition. You can do those problems on your own. The first problem is called 1, 2, 3, not 3, but 3, by Noah Smith, Kevin Gimbo, and Jason Eisner. It deals with counting the number of parse trees of sentences. And the second example is called Fake Paper Shelf Maker, which is again related to this problem of grouping nouns. It was written by Willie Costello, and it uses Japanese noun compounds as the material for the problem. And once you solve those problems, you can go back here and find whether your solutions match the official solutions. Now let's look at other types of ambiguity that appear in natural language. The first kind is morphological ambiguity. Joe is quite impossible. It means that Joe is not possible. The word impossible can be morphologically analyzed as not possible. I am means negation. Whereas if you look at a similar word, Joe is quite important, the word important looks superficially similar to impossible, but it means something very different. It doesn't mean not portent. In fact, portent is not a word by itself. So important is misleadingly considered to be a negation when it's not. Now, phonetic examples. I already showed you this one before. Joe's finger got number. Now, number can be pronounced as number if you don't know what the whole sentence means. And similarly, the word finger is different from the word singer, which comes from sing, which has a very different pronunciation. And finger doesn't come from the word fing, which doesn't even exist. There can be also ambiguities with parts of speech. For example, Joe won the first round. The word round can be either a verb, a noun, or an adjective. In this case, it is a noun because it's preceded by an article and an adjective, but in other contexts, it could be a different part of speech. There can also be syntactic ambiguities. Called Joe a taxi. So this sentence can be either that you want to hail a cab for Joe, or you want to name Joe with the name taxi. And then we have propositional phrase attachment. This is a classic example. Joe ate pizza with a fork. With a fork can relate to pizza, or it can relate to ate. So if it were to refer to pizza, it would mean that somehow the pizza is connected with the fork, which is definitely not the case here. In the second interpretation, with a fork modifies the verb ate, and it tells you the way that Joe ate the pizza. With meatballs, if you use it in a sentence, you would say Joe ate pizza with meatballs. In that case, with meatballs modifies pizza. Joe ate pizza with Samantha. Definitely the Samantha was not part of the pizza, so it modifies ate. And finally, Joe ate pizza with pleasure. Again, with pleasure modifies ate and not pizza. Sense ambiguity. Joe took the bar exam. So bar exam can relate to many different senses of the word bar. In this case, it is probably the legal sense of bar as the association that qualifies lawyers. But if you want to be really funny about it, you can also interpret it as taking the exam in a place where you can have drinks. There is also modality ambiguity. Joe may win the lottery. So Joe may win the lottery gives you essentially two possible worlds. One in which he will win the lottery and one in which he will not win the lottery. And may is a way to hedge between those two alternative futures. Let's look at a few more examples of ambiguity. There's subjectivity ambiguity. Joe believes that stocks will rise. If you hear a sentence like this, it should not lead you to believe that stocks will rise. It just indicates that somebody believes that the stocks will rise. So this is a subjective opinion or another instance of modality. The next example is CC attachment. So CC stands for coordinating conjunction. Those are words like and, or, and but. The example is Joe likes ripe apples and pears. The ambiguity here comes from the fact that the conjunction and can link just apples and pears, but it can also link ripe apples and pears. So in one of the examples, the pears are ripe, and the other example, the pears are not specified as either ripe or not ripe. Negation ambiguity. Joe likes his pizza with no cheese and tomatoes. The negation starts with the word no, but whether it applies to just cheese or it applies to no cheese and tomatoes is ambiguous. We also have referential ambiguity. Joe yelled at Mike. He had broken the bike. The word here that we are interested in is he. Does he refer to Joe? Does it refer to Mike? Or does it refer to another person? Well, we can infer from the context that it probably refers to Mike because otherwise Joe wouldn't have any reason to yell at him. Now let's look at a very similar example which has a different interpretation. Joe yelled at Mike. He was angry at him. Well, what does he refer to here? Is it Mike or Joe? Well, it looks like it's, again, fairly straightforward to interpret this sequence of sentences as he referring to Joe, because when people are angry, they yell at each other. And in this case, Joe is angry at Mike, and therefore he yells at him. So he refers to Joe, unlike the previous example. A reflexive ambiguity. John bought him a present. What does him refer to? Well, could it refer to John? Probably not. In that case, you would have to say something like this. John bought himself a present. Himself is a reflexive pronoun that explicitly refers back to John, whereas in John bought him a present, him must refer to another person. One more example of ambiguity is what is known in linguistics as ellipsis or parallelism. Joe gave Mike a beer and Jeremy a glass of wine. So we have a sentence that consists of two phrases, one where Joe gives beer to Mike and one where Joe gives Jeremy a glass of wine. Yet Joe gave is missing from the second sentence. It can be inferred from the parallelism of the two components of the sentence, because somebody is receiving a drink, so that person is Mike in the first example, Jeremy in the second example, whereas the person who's giving the drink is only shown in the first half of the sentence, that is Joe. It's missing in the second sentence, and therefore by parallelism we can infer that it has to be Joe again. So the full sentence would read something like this. Joe gave Mike a beer, period. Joe gave Jeremy a glass of wine. And one final example of ambiguity is what is known as metonymy. Let's look at this sentence. Boston called and left a message for Joe. Well, the word Boston here is not used in its literal sense as the city of Boston. Instead, the sentence means that the office in Boston called, or more specifically, a person in the office in Boston called and left a message for Joe. So when word or expression is used to refer to some other expression instead, we have an instance of metonymy. In addition to ambiguities, there are many other sources of difficulties in natural language processing. For example, non-standard slang and novel words and usages. Those come up all the time. So let's look at some examples. A360, this is a model of an airplane. The next thing is a number. There can be an infinite number of different numbers that you can see in a text. Phone numbers can be formatted in many different ways, with a plus at the beginning, with parentheses, with or without hyphens in the middle, and so on. The word spam used to be a kind of food, and now it's used as a verb, indicating that you're sending somebody an unsolicited email. The word friend used to be a noun, but now it is used as a verb, as in he friended me on Facebook. Some of the words that you see on the list here were recently recognized as dictionary words. They did not exist a few years ago. For example, YOLO, for you only live once, selfie, for a picture that you take of yourself, and chillax, which is a combination of chill and relax. Those words were recently added to major dictionaries. In fact, if you go to Urban Dictionary, you will find a lot of novel words that have very unconventional senses that you still have to be able to process in a natural language system. The only warning that I have for you is that this website is very much R-rated, and you should only be looked at with parental warning. There are also inconsistencies in text. For example, a noun compound such as junior college is a type of college, whereas a compound like college junior is a type of person. Even though the two phrases have the same words, they mean very different things. There's also a very major difference between a pet spray, which is a spray for pets, and a pet llama, which is just a small of a llama. You can see that even though the two sentences have the same structure, they have very different interpretations. And then I explicitly spelled this wrong, typos and grammatical errors. Things like receipt, which people tend to spell incorrectly very frequently. John Hopkins instead of Johns Hopkins. Should have instead of should have. There's also parsing problems that you have to deal with. For example, what is a cup holder? Well, a cup holder could be a person who won a cup, for example, a cup in golf, or it can be a tool inside your car, which is used to hold a cup while you're driving. Federal Reserve Board chairman, again, can be parsed in many different ways, and later on in the class we're going to look at how many different ways, in fact, there are to parse this sequence of nouns. The intended interpretation here is that we have a Federal Reserve, which is a United States national organization. The Federal Reserve has a board, and then a specific person is the chairman of the Federal Reserve Board. What other sources of difficulties can there be? They can be very complex sentences. We looked at some examples of those before. They can be counterfactual sentences. For example, if you were to do this, then that would happen. Humor and sarcasm. Computers have a really hard time dealing with humor and sarcasm, as well as metaphor and other non-literal usages of words. Implicature, inference, word knowledge. This refers to cases where a sentence can only make sense if there is enough shared knowledge between the people who communicate. For example, if I say, I was late because my car broke down, a normal person would understand this sentence without any difficulty. However, a computer would have a hard time because there's a lot of implied knowledge that was not explicitly said in that previous sentence. For example, my car broke down implies that I own the car. I use the car to get to places. It also means that the car has wheels, that the car can brake, and that when a car breaks, that causes you to be late for a meeting. So what is not explicitly mentioned is very important for a computer, and also what is word knowledge. Very often you cannot come up with any reasonable interpretation of a sentence if you don't have access to the implied knowledge that humans take for granted. There's also a significant difference between semantics and pragmatics. A sentence can be semantically correct, but it may have a specific purpose which can only be caught by pragmatics, which is the study of how words and sentences are used in a given context to achieve certain goals. For example, if somebody asks you, do you know the time? What are you going to answer? I mean, some possible answers are yes, I know the time, or I do. Obviously, those are correct answers, but they're not what the user, what your interlocutor wants to hear. They want to ask you for the specific time. And language is hard even for humans, so we shouldn't be surprised that even computers have problems with it. For example, for humans, there's a distinction between learning L1, which is your native language as a child, and learning L2, which is learning a foreign language. Both of those are known to be very difficult to learn. Another instance of confusion in natural language processing is the use of synonyms and paraphrases. Synonyms refers to words that have similar senses, and paraphrases refers to phrases that have similar senses. So let's look at three sentences that come from the Dow Jones. The first sentence says, the S&P 500 climbed 6.93, its best close since a certain date. The second sentence says, the Nasdaq gained 12.22, for its best showing since a given date. And finally, the Dow Jones Industrial Average rose a certain number of points, its highest level since March 15th. You can see that the three words on the left, climbed, gained, and rose, are pretty much synonyms, at least in this context. Similarly, the three phrases on the right are paraphrases of each other. Its best close, for its best showing, and its highest level indicate the exact same meaning in those three examples. And the reason why the Newswire uses different words is just to be more natural. You don't want to hear the exact same sentences, the exact same words used all over. So in the next segment, we're going to look at some of the background that is needed to build natural language processing systems, specifically the linguistic and mathematical background.